All right, here we go. This is today. We're learning about what? A linear system, right there. Okay. All right. So what is a linear system? Eyes up. Stay with me. It says a linear system is a collection of linear equations that involving the same set of variables x and y. The system below has two linear equations in the same two variables x and y. So this is what they call a linear system. Two equations with the same variables x, y, x, y. My only question to you is this. Nobody today has answered this question. Not period 4, not period 5. No, wait. Period 5, maybe they did answer it. What makes this equation and that equation linear equations? Think about it, raise your hand. Think. Cassie, what do you think? They have x and y intercepts. She is correct about what she said, but that's not what makes these linear equations.
X and Y are on the same side.
X and Y are on the same side. That makes them standard. They're in standard form. That's not what makes them linear. What? Equal sign, that makes them equations, not linear. Hey guys, you know what this is? You know what that is? That's a quadratic equation. How'd you know? X squared. How do you know it's linear?
Just a regular x.
It's a regular x, and also there a definite answer to it.
No. What do you mean by their regular x?
You're not changing, like you're not multiplying it. You're not.
No.
Not,
John, what were you saying?
I was saying the same thing, to where it was just a default x without any exponents.
Oh, that's closer. You're closer. He says without any exponents. Guess what? There are exponents. X to the first and y to the
first.
Guess what? This is what you do. You just look. You look at the exponents. X to the first, y to the first. X to the first, y to the first. Guess what? This is linear. That over there is what?
Quadratic.
Because it's 2. Power of 2, quadratic. Power of 1, linear. And by the way, linear means what? Lines. What does quadratic mean? Parabola, use. Okay. All right. And that's what we're doing. You have to find the answer to this system. What's the answer? It's right here. A solution to a system will be written as an ordered pair x, comma, y. To be the solution, it must satisfy what? Both equations. So here's my first question. Is 4, -3 a solution to this system up here? How would you know?
Plug it in.
Okay. Where does this 4 go?
X.
In for x, right there. And the -3 has to go in for what?
Y.
Y. If it works in both equations, it is the solution. So this is where you get that pencil moving. 5 times what?
4.
4. 7 times what? Okay. I get 20 plus -21, and the answer is -1. But what did I want? I wanted 1. It says right here, 1 must equal 1. Is this working? No. Your answer should be no. It's not a solution. It didn't even work in the first one. It's got to work in both. Once I plugged it in the first one, it didn't work. There's no sense in trying it in the second one. How about that point? How about that ordered pair? Is that the solution to this system? Well, let's try it. 3 goes in for what? X. -2 goes in for what? Y. 5 times 3. Plus 7 times -2. 15 plus -14 makes
1.
1. What do you want?
1.
1. Check. It works. So is that the answer?
We don't know yet.
You don't know yet until you check both equations. Check the other equation. 3 goes in for x, and negative 2 in for y. So that'd be 4 times 3. Take away y. Y is what? Negative 2. 4 times 3 is 12. 12 take away 2. Double take away.
Plus 2.
Turns into plus 14. What do you want?
14.
14. Check. Is it the solution?
Somewhere.
Yes.
Are you recording?
Yep, it's recording.
Oh,
Okay. All right, guys, we just found the solution because we checked it in both. It worked in both. We're good to go. We got it. This is not the answer. This one doesn't work. It didn't even work in the first equation. No sense in trying the other equation. All right, so what's this last little sentence say? One way to solve a system of equations is by graphing. You can graph both equations. Right here, graph both equations. When you are done graphing, look for the intersection point that both lines share. This point is known as the common solution. So you might get this look right here. Today when you do your assignment, you'll graph. And you'll look for points that they share. Now, is this the point that we're going to call the common solution? No, this is a solution. But it's only a solution to how many of the equations?
1.
Just one equation. It only works for one. This point works for what?
1.
1. This point works for what?
None.
None. This point is the what? This is the common solution that we're looking for. So all you care about today is where do they what?
Intersect.
Where do they intersect? Wherever they intersect, that's the answer. Okay, we're not doing that for another page. We got to still talk a little bit. Okay, here we go. Here are some of the possible solution sets that you might get when you graph today. One of them is known as you graph and you get what?
Intersection.
Lines that intersect. Pretty obvious. Intersecting lines have how many solutions? 1. It says right here you get one solution. You might graph a line and another line, and guess what? They lie on top of each other. They're known as coinciding lines. They just lie right on top of each other. So where do they touch?
Everywhere.
Everywhere. So, how many answers are there?
Infinitely many.
Yeah, it says right here, coinciding lines have so many answers, you just say what? Infinitely
solutions.
Many solutions. You have to say that. If you're lazy, you can write IMS, says Taylor. Taylor, are you lazy?
Oh, yeah.
Okay, he's writing IMS. All right. Next, you could graph here, and the lines are what?
Parallel.
Where do they touch?
Nowhere.
So if they don't touch, you say what? You write the words, no solution. No, don't write NS, okay? No solution. All right?
Doesn't no solution have a symbol?
Yeah, it does. What's the symbol for no solution?
Or equal sign with cross.
Circle with what?
Okay.
That's called the empty set. Empty set means there's no answer.
Okay.
All right, now, look up, because this is where it gets a little weird on you. They also call these systems, they give these systems a name, and these are names that most kids don't remember. They don't take time to remember. But see this word consistent? To me, consistent just means you're going to get answers. In this case, how many? One. Here, they call this system also consistent. You're getting answers, but how many?
All of them.
Millions and billions. When you get no answers, they call it what?
Inconsistent.
So it's consistent, and then what? Inconsistent when there's no answers. It has to be this system right here. Memorize it, because they're going to ask you questions about it. And then they call one answer an independent system. They call millions and billions of answers. They call that a what system?
Dependent.
A dependent system. They give those names out, and then you're supposed to memorize them, and it's hard to memorize them if you don't make them somehow make sense to you. Okay, so consistent meant what?
Those the answer.
You get answers. Okay, but if you get one answer, they call it independent. If you get millions and billions of answers, they call it dependent. Okay, when you get no answers at all, they just give it that name. Inconsistent. Try memorize. Okay. Here's a couple questions about these systems. Inconsistent linear systems. Are you looking at the right one? Inconsistence, which one? It's that one. Okay. Intersect at 2 points, true or false? Okay, false. An independent linear system, that's this one right here, has one solution. True. Okay. A dependent linear system, which one's dependent? The middle one. Has no solutions. False. And finally, two unique lines. Unique is different, right? So two lines that are different, so they're not the same line, different, with the same slope, form inconsistent systems. Yeah. Two unique lines that have the same slope. Same slope because they're parallel. Form inconsistent, that's true. Okay? False, true, false, true. Did it make sense? It forces you to look at the pictures is what that did. You had to keep looking up here, didn't you, when you try to answer those questions? Keep looking at this when the questions are on your homework today. All right, here's your first try at it. Ready? This is your first and probably last try. Because, no, I guess we do it one more time down here. Graph this system. Tell me where they intersect. I'll give you a 1 minute head start. I'm not going to tell you anything. I taught you how to graph in chapter 2. You know how to graph. You get a minute head start. There, I solved for y. So what I decided right away is I'm just going to solve for y, put it in slope-intercept form. So I took the top equation, solved for y, I got that. 3/2 x plus 4, which tells me to start where? Up 4, okay. Now where? Rise over run. Up 3, right 2, up 3, right 2. Okay, there you go. This side of the line is done. The other side of the line would be reverse your slope. Say it. Down 3, left 2. Down 3, left 2. Yep. Right there. 1, 2, 3, left 2. Run 2. 1, 2, 3, left 2. There's the other side of the line. There it is. You what?
I thought you were talking about the other equations.
No, I just meant to get the other side of the line, you have to reverse your slope. Okay? Now, what about this line, or this equation? Solve it for y. So I would subtract x from the negative 8. I would get these to cancel. 2y equals, I'd put the x first, minus 8 last. Divide by 2. Once you divide by 2, you get y. Divide by 2, divide by 2. Help. What's the number in front of x?
-1/2
Negative 1/2 x
minus
4. Graph this. Start where?
-4.
1, 2, 3, 4, right by here. Slope is
Down 1 over 2.
Left
down
two.
1. When you guys say
Right
over,
two.
what's over?
Left or right?
You gotta say left or right though.
Okay. Down 1, right 2.
There you go. Down 1, right 2, down 1, right 2. Down 1, right 2, 2, 2. Okay. You know what, guys? I'm kind of going the wrong way. I'll never hit that line. Reverse your slope. Up 1, left 2, up 1, left. I got it. There it is. I already hit it. There it goes. This way. You should know the solution to this system. Just by looking, you see it intersecting where? -4, -2. We think that's right. But there's a huge possibility you did it wrong. Because you graph one line wrong, it's going to be wrong. Right? So do what?
Check.
Check. And check doesn't take long. Just put in -4 for x and -2 for y. Here I go. First equation. -4 goes in for x. And -2 goes in for y. You get 12 plus what? -4. Together that makes what? That makes 8.
Yeah.
What'd you want? I can't see it. It's up there. I can't see it.
You want 8.
You want 8. Check. It's good. Okay, next. Check this equation. X plus 2y. X is -4. 2 times y. That'd be -4 plus
-4.
-4 makes
-8.
check, check, right? Works in the first and works in the second. You got it right. All good?
Yeah.
Okay. Guys, do you remember this in 9th grade or am I surprising you?
No, I kind of remember.
You shouldn't be saying kind of. You should be saying, yeah, I remember this.
Question.
Most of us have-
Yeah.
Does
Go
it
ahead.
not work to use the y and x intercepts?
Say that again.
Does it not work to use the y?
It does work to use the XY intercept. The only problem I don't like about the XY intercept is right here. Let me show you. If you look at this number 8, is 8 divisible by 2?
Yeah.
Yeah, so that's a good one. Is 8 divisible by 3?
No.
Not evenly, and what you're going to get is 2 2/3-ish. Now you got to graph 2 2/3, and then you got to draw straight lines and hope they intersect at a nice point. It works, it's just not the greatest method.
Okay.
I only use that method when I look at that number and go, 8's divisible by 2, 8's divisible by, 1. 1's a nice one. You could use that method on this one really nice. This one, not the greatest. Okay, here it comes. This is the one we're talking about. This would be your story problem. Here we go. Your school sells tickets for its winter concert. Student tickets are $4. Adult tickets are what? 8. Okay, guys, they're giving you information about the tickets. This next sentence, if your school sells what?
200 tickets.
And makes
$1,000.
$1,000. You guys, when you read these story problems, most of your story problems have totals. Like a total and a total, you have to write 2 equations. Usually your totals are going to be the right side of your equation, usually. Here comes the question. The question is, how many? It says right there, how many what?
Of each ticket did they sell?
Okay, so how many of each ticket did they sell? That would be you representing your variables, x and y. You always have to tell me what you're looking for. You're looking for x, you're looking for y. So x would be the number of,
Students.
don't say students.
Adult tickets.
You can say students or adult, but listen, how many of each ticket
$4.
did they
Sell.
sell? You can't say students, you gotta say,
$4.
Number of that many.
you can say students, but you gotta say student
Tickets.
tickets what?
Sold.
Sold. You gotta know what you're looking for. How many student tickets were sold? 20, 30, 40, 70, 80, 90? What? What would y be?
Adult tickets sold.
Yep. Okay. Now I know what I'm looking for. I'm looking for how many did I sell? Students and adults. But you know, when you write your system, you have to think, they want me to write two equations, linear equations. Okay, on this side, usually I look for the total. You guys, I kind of underlined it right there. What does that say? Okay, so here's the deal. You know you sold a total of 200 tickets, so you should be thinking this way. Total tickets here. Well, if that's total tickets, it has to be tickets plus more what?
Tickets.
Tickets. So tickets plus tickets equal tickets. Total tickets. Now, how many student tickets did I sell? I do too, no. It's right here.
Plus Y.
I sold this many. X student tickets were sold. That's a number. Plus what? Y adult tickets were sold. Those are just numbers. Equals a total of what?
200 tickets.
200 tickets. So guys, your equation would be what? There it is. In your mind, when you see X plus Y, don't say X plus Y, say this. The number of student tickets sold plus the number of adult tickets sold equals 200 total tickets. Does that make sense? Tickets plus tickets equals tickets. Now the other one is not going to be tickets. It's what?
Money.
It's money. So it's money plus more money equals total money. How much total money did we make?
1,000.
Okay, but how did we make 1,000?
4x.
Okay, why 4x?
Because it's $4 for each.
$4 for every student ticket sold plus
8Y.
8 times the number of adult tickets sold should give me $1,000, right? Good? Guys, you just wrote a system. Your job is to find where these two lines do what? Intersect. Okay, that's it. Now, a quick comment about story problems. Story problems, when it comes to graphing, don't solve for y. It gets way too hard. The numbers are way too what? Large. Don't do it. Don't solve for y. Go find your x, y intercepts. It's so much easier. Okay, for instance, watch this. If you try to go find your y-intercept, it's 0 comma something. Your x-intercept, x comma 0. Just put 0 into your equation. Here we go. Come around the corner, go up here. If you put a 0 in for that x is gone. What does it say?
Y equals 200.
Oh, so would that be a point on your graph?
Yes.
0 plus 200 equals 200? Does it? Yeah, 0 plus 200 equals 200. What would happen if I put this 0 here in for the y?
X equals 200.
Cover up the y term, x equals 200. Would you agree that's the other intercept? 200, 0, 0, 200 works. Graph this point, graph that point, you got a line. But don't graph yet. Now go find what? The x-intercept and the y-intercept for the other equation, right? Here we go. Put 0 in for y, right here. Cover up the 8y. What's it say? 4x equals 2, oh, sorry. 4x equals 1,000. Divide by 4. 250. You got to get good at this, guys. You really do. 0 goes in for what this time? X. Cover up the x term. 8y equals 1,000. I don't expect you to know this. Would you just divide? Okay. Just yell the answer up. Don't be so quiet about it. Okay, 125. Okay, now I have a point and a point on my line and a point on a different line. Graph. Look how big the numbers are.
Big.
You can't go by ones, you can't go by twos. 50s. That's very fast. You're going to get there so fast. I don't want to get there so fast. I want to spread it out a little bit. 25? I like 25. Every 4 would be 100. There's 100. There's 200. And there's 250. I'm going to do the same on the y-axis. 100, 200, and 250. Now, Taylor wants me to go by 50s. If I go by 50s, do you know how fast I'm going to get to those numbers? Your graph will be way down here. It'll be in this little corner. I'd like to spread out the graph if I can. You could have went by 10s or 20s if you wanted. Okay. Now, you know what I didn't do? I did not label the XY axis. What's the Y axis called? What's the X axis called? What's Y? What did Y stand for?
Adult.
Adult tickets. Number of adult tickets. Which leads me to believe that the x-axis must be number of what? Student tickets, right? And I probably should say sold, right? Okay, graph the first equation, 0, 200, 200, 0, right here, and right here. Draw the straightest line possible, take a pencil, another pencil, and just line it up, and then just draw the straightest line you can.
Cheater.
I know I can cheat. I can cheat because I got tools. Next,
That's not cheating, that's using your resources.
that's using my resources, that's right. Where's the other one? 125. 250 zeros here. And 125 is here. There we go. I did the best I could. You guys do the best you can. And now our job becomes picking up the intersection. Anybody want to try it? Where'd they intersect? Somewhere, yeah, somewhere. Okay, I'll show you where. Right here. Right there. Right there and right there on my graph. What is it?
150.
Taylor says he thinks he sees 150, 50.
I think 160.
Okay. Here's how you check it, right? You stick them in. Here, I'll put 150 in for X, 1 and 50 in for Y. Is it equal to 200?
Yes.
Works in the first equation. 150 in for X here. What's 4 times 150?
600.
600. 8 times 50. 400. What's 600 plus 400? Did it work? It works. That's it. We got it. That's the answer. We got it. Here's my question. Did it look like 150-50 on yours? Yeah. So here's the deal. Is this a great method? No, this is like the worst method. Graphing method is the worst method because there's so much room for what? Error. This is not a good method. I'll teach you another method tomorrow and Wednesday. Okay? Oh, by the way, we're not done. You need to say this. At the end of a story problem, you need to say this. The 150 stood for what?
Student tickets sold.
Right. You have to say this. Otherwise, how do I know what 150 means? 150 student tickets sold? Where the 50 means what?
Adult tickets sold.
Adult. Okay? Say it that way. Because if you don't say what 150 meant and you don't say what 50 meant, I'll give you most of the credit, but not all of it. Okay? Next page. If you notice, the next page looks like kind of a review of what we talked about on page 2. You're right. Here's what they're doing. They want you to look at your systems, and then they want you to look at your systems and then compare the slopes. compare the slope and the y-intercept of all your systems. So if you have an intersecting system, okay, which would be called independent, by the way, what about the slope of your two lines? Say that again. They're different. They have to be different because different slopes mean they're not parallel. They're going to touch somewhere. So they're different. And once you say that, once you say the slopes are different, you know they're going to intersect in how many spots? One. You don't even care now about the y-intercept. You don't care. If you know you have different slopes, you have intersecting lines. One answer. Okay. But now look at the next one, this next system. Coinciding lines, if two lines are coinciding, they lie on top of each other. What do you know about slope?
They're the exact same.
Same. What do you know about the y-intercept? Same. So if you ever say, I have the same slope, I have the same y-intercept, I have what system?
Coinciding.
Yep, but it's called what? Dependent. This one's called what?
Independent.
Independent. Okay. When will you have an inconsistent system? When the slope is what? Okay, same. But what about the y-intercept? Different. They're separated. So you have this going on, it's this one. It's inconsistent. Now, you see these three systems down here? You have to determine which one is independent, dependent, inconsistent. Okay? Without what? Which means all you have to do is figure out the slope of this line and this line, and of course the y-intercept. Because the y-intercept gives it away, so does the slope. So on this system down here, this is the only one I'm going to do with you. Go figure it out. Which system is it? This one? This one? Or that one? Okay. Go find your slope. Go find your y-intercept. All right, I took my top equation, I solved for y, I got that. Is that what you got?
Yeah.
Okay, that was not the hard one. That was actually the easy one. This one is a little harder. Bring this over here. How? Okay. This is the hard part. How do you get rid of a multiplier that happens to be a fraction? Multiply by, the word I was hoping you'd say is reciprocal. What's the reciprocal of negative 1/3?
1/3.
Negative,
Oh, and it's just
negative 3 over 1. Do the same over here. This 3 and this 3 cancel, right? Negative, negative. You get your positive y. There you got your y. What's negative 3 times negative x? Right here.
3x.
Positive 3x, right? What's this? Yeah, negative 3 times 1? Negative 3. Now your job comes down to this. Compare the two equations. Same or different slopes. Okay, so you're telling me same what?
Same slope, different way.
Same slope, but y-intercept? Look at the y-intercept, same or different? Different. So yeah, same slope, they're parallel. Are they touching everywhere? Or are they separated? They're separated, why? The y-intercepts are what? They're different. So which system is it? inconsistent, right. No, no, no. Is that right?
Yes.
You have,
Farther up.
yeah, farther up. Okay. You have what?
Parallel and
Yeah,
inconsistent.
it's inconsistent. So you should be saying what here? Inconsistent with this one, right? Okay. That's it. I'm not gonna do the next two because they're the same. You compare the slope, you compare the y-intercept. Alright, now. If you wanna do the other two right now and ask me before you leave, is this right? I'll tell you. See this is your assignment, it's 1 through 13. You have to graph 9 of the 13. 9? 9. Here's, yeah, I do watch this. Here's some graph paper up here. Take a look at that. Almost forget. Here's your homework. Here's your homework. Come on up, grab it. And your text can go right on my stool. My stool has your text. John, you want what?
You have to do any 9 or?
No, the first line says graph.
Oh, I could say something worse than that.
Your test belongs on my stool. You need a blue sheet right now. How much money?
Put it on the stool.
Oh my gosh. It's
My
overwhelming.
hungry.
It's overwhelming.
Thank you, thank you.
You get extra one.
Tyler, you must be on the floor. Okay, all right, we're done. Boom, ba-dum, ba-dum.